Okay, now we're going to do this, this upper sum. So remember, what this looks like is, in general, of course, we have concavity is up here, so this will be throughout the interval. We'll be able to achieve this coming in like so. We'll get all of our rectangles circumscribed, and we'll be taking our C sub i's off of the right side of each rectangle. So to achieve that, all we have to do is have the C sub I. So this is for upper sum. In this instance, because we have concavity up. I keep saying that because if you have a mixture like this, then taking left sides won't always give you a lower sum. Likewise, taking right side won't always give you an upper sum. So your C sub I could be mixed depending on your interval. Thankfully, we don't have to worry about that for this curve. And it turns out really for any curve, it doesn't really matter. Taking left sides is good enough as anything. Doesn't even have to be a lower sum. Okay, let's continue over here though. So here's our C sub I, which is just going to be I times the delta x. And of course the delta x is just b minus a over n, which is just 2 over n for this problem. Okay, so our C sub I actually is 2I over n. Okay, so in our sum here, we're going to have our upper sum will be this from 1 through n. We'll have f of 2I over n times the delta x. And let's go ahead and put in our numbers now. 1 through n. F of 2 sum I, f of 2I over n becomes 2I over n squared plus a 1, like that. And then times the delta x, which is 2 over n. Okay, so that's everything. Notice it's a little simpler than the last one, but we still have to do some expansions here. So we have a 2 over n, and we'll have this sum. The first one in here is going to be a 4 to 8 I squared over n squared, and then plus a 1, like so. Okay, and that we can break into two pieces. We'll have this first one, and I can pull out that 8 over n squared for the first one. And the second one is just going to be the summation of 1. Okay. And this would come now 2 over n. This first term is going to be 8 over n squared. Summation I squared again, which is the n plus 1, 2n plus 1 over that 6, remember? And then this other one, summation of 1 is just going to be n. Okay, so now if we do a little expansion here, let's expand over here. We're still going to get that 8 over 3 in here, and we'll still have, it looks like the n plus 1 times the 2n plus 1. And underneath here, we'll have an n squared, like that. And this other term will just be a 2. So now, let's leave it like that. That's our S of n. And if you want to let n go to infinity now, you're going to have, remember over here now, you get that same situation. You've got a second degree polynomial over second degree, so you're going to have the, your limit will be the ratio of the leading coefficients. So it'll be 16 over 3. And then, of course, this 2 over here is just a 2. So again, you're at 7 1/3. So those two limits did show themselves to be the same.